So moving forwards, the scatter, you would see, hey, what's the scatter? Well, the scatter is a bunch of houses at the back. These are all instant. So when I move forwards, it looks like it has some parallax. So this is actually very simple. It's just a simple copy the points. But I am doing a couple of more things here because there is a lot of import, which is going to be the last thing I'm going to be covering. So I made a grid where I want the houses to be, and I edited it to my desire. I subdivided it and I sculpted on top of it, like so, as you can see, a little bit, and I transform it roughly where I want this to. This is our ground, our terrain. Then I did a couple of things. These are some points for the trees, and these are points for the houses. These are two different things, which the trees are going to be covered later on. But for now, the houses, I'm going to add a mask. If we visualize this mask, it's something like this. It's based on X and Z. From basically 0 to negative 750 is going to be 1 and 0. I'm going to be scattering points based on the mask. As you can see, there are more points at the back than on the front, and I'm going to be distorting the points a little bit so they are moving. I'm also doing a variant because I have 6 different houses. I'm going to be adding random between 0 and 5 because this value goes from 0 to 1, and 1 is almost never possible. So basically, if I multiply everything to 6, it's going to be from 0 to 5.99. And basically, then if I floor this, everything is going to be from 0 to 5, so 6 houses in total. With another expression, I'm going to be creating the orient. Basically, everything is just a simple orient, which is doing nothing right now. I'm just creating it as a vector 4 and setting the scale because some houses can be, they are going to be all the same on the x-axis, but some of them are going to be smaller on y and way smaller on z. So basically, some of them are going to be squashed a lot. Then I'm going to be setting the orient again. Basically, it's going to be moving a lot on the y-axis, so it's going to be rotating a lot here from this value to another value, and I'm transforming these points because I'm then basically what I'm doing is then enlarging this because I ended up needing way more space between the houses. And then the scale is, I'm going to change it so it's smaller at the back. So I'm basically faking how much I'm going to have. And with this frustrum from camera, which I created in previous videos, which I'm just going to explain briefly, the key part of this, I'm basically blasting all the points. It's a box. This box has to be, there we go, on the positive Z and positive X. I'm getting the front right here, and I'm getting the back right here. I'm promoting this all the groups points. And with the primitive, I'm basically saying how long I want this box, how big I want this box to be, and then I'm enlarging this to my desire, to my maximum distance, the one I wanted. I wanted 6,000 meters. Basically, I'm just extruding with a simple function on the set. This is always going to be the same one. And I'm adding this, which is the key part, is from NDC Geo and grabbing the frustrum camera, which is a static camera. It's like one frame of my camera, and it's creating this value. And with this, which is the code, I'm just going to go to the bottom. You don't need to learn anything from this because we're not using it, nor this one. I'm just going here, which this is the input. This is the camera. I'm grouping all the points, and I'm just blasting them. That's all I'm doing. Of course, you can access to these tools on the Patreon if you already didn't. These are all posted there. So I have this points, which all of them have an orient attribute, and I have these houses. These houses, as you can see, there are a lot of them stacked on top of each other. Basically, it's like having a lot of packed primitive, because if I explode beauties, let me see if this works. Yes, this won't work because they are all stacked on top of each other, but I could separate based on the naming. As you can see, we have the geo bar 0 from 0 to 1. So I could blast this. I could also blast and show you. This is one house. This is another house, and so on, right? This is very important because I'm going to quickly go to stage if it doesn't explode. And what I did is to grab this USD, which is, I'm going to explain how to do the USD later on. This is this has more variance inside it, the house, inside the asset, and then I'm just transforming this to my needs, and I'm basically exploring the variance. Exploring the variance means, hey, reveal everything that's inside, and you will see it's already very familiar to what they have in subs. The only thing I needed is to add a collection. The collection, if I go into Solaris real quick, basically is grabbing from all these geometries. I'm just dragging it right here. That's all I'm doing. I'm setting everything into this little connection. And if we Control C once we have this collection, and we go to our scatter right here, we can see we can import the same stage node, this Control B, and grabbing the primitives, which everything that's inside this collection, the house collection. I'm grabbing the proxy, but I could be grabbing the render. I just want to grab the proxy. Everything's going to be packed. So then if I just paste, what I'm going to be having is this, which are all the houses accordingly with all the variations. So if I change this, they're going to be moving more or moving less. And that's pretty much it for the scatter. I'm then just adding, and I'm also adding a little random value, which is called prueba. We can visualize this right here, which are going to be some color information, which is going to be used in shader. The same deal if for the trees, exactly the same deal. This is exactly the same as this one. Then we have a bunch of effects going on here. Let's begin with these smokes. These smokes are just meant to be working at the back, which is basically here. This is really at the back. If we were to see it with the houses, with everything here, we go here, we will see that this is somewhere around there. Okay, it's between the houses. Oh wait, let's put the houses in display right here, right there. So what I did here is a simple, very simple setup. I'm grabbing a sphere, which is this one, the middle, or not really the middle, but it's moved around here. And there is a frustum from a static camera, the one we blasted the houses. This shape is just with a simple, I just turn on the noise and I just turn on the deformation, and then I translated this here. The density is set to 2 and the pressure is set to 1, so it has a little bit of expansion. And I simulated everything, and it just turns out to be great. Usually you like to have a staff frustum, so it's easier to simulate, but you also want to have a little bit more padding because light is going to be affecting this shot. So that's the smoke C. The smoke B is a little bit different because there was a mistake in how it's simulated at really far distances. So what I did is to have it everything near the center, roughly, with the same frustum. You will see I move this this amount of meters backwards forwards. And I also moved this camera frustum 2 forwards the same amount. I had to do like a workaround because I'm going to simulate and then I'm going to be moving with a simple transform this back to where it belongs. As you can see, I simulated here and I move it and I place it there with the frustum also being moved there. That's the workaround I did with a simple bug that was going on. So it looks something like that. Very nice. These are some just simple Pyro bakes for the visualization. This is the visibility if I want or don't want anything. And these are a sample because in some places we might want to have a reducted visualization, and also it's sometimes useful to do phantom layers with text. If I go to beauty, this is how it looks, but if I go to volume, okay, this doesn't move. But in the foreground, I use this trick where if I go to beauty, the shadow is going to be casted by a reduced version of the actual volume, which is way faster. Oh, and here, this is a very nice trick. I grab this sculpt. Let me go to the main. I grab the sculpt. I also added the same. Oh, this is not working. Oh, because it's this one. Okay. I grab this sculpt. I transform it the same as the houses. I frustum it a little bit. I turn shift it because the camera is moving, and I'm scattering a bunch of points. Then I added a grid with the settings to match size with these settings on top and scale to fit. I faceted it. I added a connectivity. So basically, if I show you how it looks, I'm having a bunch of colors. Each one is a different simulation. I extruded it backwards, I reversed it, and then I created this. This is simply for each connected piece on points, on class, and I'm grabbing, you will see, I'm grabbing the wedge, which is getting driven by this, which is basically grabbing the num iterations from this simple for each loop, and then I'm creating a wedge. This wedge is going to be driving basically these points right here. We'll see this box is going to be moved, so we are going to be watching the simulation, and I'm going to grab these points and I'm going to be grouping these and blasting. So I'm going to just be simulating this and adding a bunch of noise on the density. You will see it looks something like this. Very nice. And grabbing another one, I'm multiplying everything so it's a little bit more noisy. I'm blasting all the points that I don't need. I'm adding temperature on top of it, and then I'm rasterizing this. This is going to be my source, which is going to be moving. And you will see that if I watch or if I look at this, let's let it load. Oh, it's grabbing all the wedges. Well, you will see we have all these boxes going on. All of them have the same resolution, if I'm not mistaken, because I don't need much more, but these will add a lot of detail of smokes and mist going on here. If I go and do something like this, you will see this is the simulation. See, there is a bunch of smoke between the houses, which is more than enough. What else? Well, the simulation is super simple. It's just dissipation, some cooling, some diffusion, some wind, and a little bit of disturbances. I didn't really think too much about this one because it was really simple. All of them have velocity, as you can see, as the control field, and the only thing is changing is the block size. The block size here and the block size here too, and the confinement is just speed up to 20. This is up to 10, up to 10, up to 10. It was actually very simple to do. There wasn't much thought into it. The most complex part is this part right here. And on the sourcing, I'm just setting the temperature to 0.6 and no pressure at all. The temperature is what's going to be driving my well, everything, the smoke going upwards. And then I'm just outputting the temperature and simulating from frame 600. with this division size. I don't remember if I explained this one, but this is probably more focused into how it's supposed to be looking. This is the division size on simulation. The cooling rate of the temperature is going to be very small. The dissipation is going to be way bigger, and there is going to be a force. The force is going to be moving my smoke from one place to another. There's going to be a lot of confinement and a lot of disturbance. But basically the disturbance and the turbulence, well, not the turbulence, but the disturbance is going to have a velocity control field with this block size, which is roughly 30 centimeters. That's how I like to think about it. Let's have a look at the simulation. This is the simulation. I also had an issue with the speed. So what I did to solve this is to reduce the time scale by 3. And the turbulence is a fast paralleling with a swirl size of 1 meter, which is going to be causing these big shapes. The small shapes are these turbulence, and the big shapes are going to be the turbulence. And the confinement is what's going to be revolving everything on its own and having everything. These are the smokes, the environmental smokes of the back. We have a lot of fire effects. This is a little bit larger, but this same concept applies. How to have good fires. Let me just show you real quick how this looks. This is very interesting. With you can do real quick file caches and playblasts, and it's all stored. I have this playblast called Fire. This is my first fire simulations with Axiom right here. They're not playing, but this is how they look. They are stringy, but we ended up going for these ones, which are way faster, but also way less stringy. The way this was developed, it was done by this. So first I'm going to get these debris piles. I'm just, well, it's just a copy paste of what we had in the collisions tab. I did it again because I wanted different settings. Just copying everything here, and I'm transforming. This is the SDF. I'm transforming this a lot. It's like I'm making them bigger, basically, because I'm going to be simulating in a bigger scale. If I'm not mistaken. But ignoring this, what I'm actually doing is to grabbing this collision polygon, which is all of here, all of the polygons of the colliders, and I'm painting. What am I painting? I'm painting the places I want the masks to be: the mask 4, the mask 3, the mask 2, and the first one. These are all the places where I'm going to be having fire. I'm calculating the normals. I'm scattering a bunch of points where I want. In this case, is the mask, then it's the mask 4, then it's the mask 3, and I'm grabbing the STF. I'm reshaping this. I'm eroding it a little bit, and I'm grouping. Why I'm grouping? Because there might be some points like these ones which I don't really like, and I'm blasting them. And then I'm saying, hey, this is the class number 0. This is the class number 1, and this is the class number 2. So I'm creating 3 variables. Why? Because I want to have, I also want to wedge this. I want to wedge this so I don't have a big simulation, but a bunch of small simulations. So as you can see, I'm blasting based on this value, which is the same trick as I showed you before with the fire. It's just a bunch of points it's generating based on this value here. I'm instead of only using wedge, I'm also adding a little bit of variation with turbulences on the simulation, but you will see in a moment. I'm adding an attribute which is a mask. You will see it's just a moving mask, if I'm not mistaken. Yeah, it's moving. I'm adding some noises to what? I'm adding noises to the color. This one, the color. These are just more noises. It's a simple turbulent noise plugged into the color field. Then I'm creating the density, and I'm randomizing the P scale. not everything is going to be having the same P scale. If I were to see this, let's see P scale, let's show this. So each point is going to be a little bit different from the other one. And then I'm grabbing the density again, where it is, right here, density. And what I'm doing is to adding a little bit from that, because I had this density set to 1 here, and I'm just multiplying a noise on top of each, as you can see. So it's moving. I can really tell right now that this is not really being used. I guess it was a previous test. Then I'm multiplying the density based on this previous mask. I'm multiplying this noise, this density, which is this one, by this mask, which is outputting this. It's like a noise stacked on top of each other. Then I'm adding another noise. This scale is what is changing. This is what changes between each other. And another one right here, which is way bigger. And I'm merging all of them together. I have 3 different types of sources. This one is very slow. It moves, but very slowly. This one moves, but way... Oh no, this one doesn't move, it looks like. And this one does move. So you have a constant, a really fast moving, and a very slow moving. I'm adding a lot of velocity, initial velocity, for the turbulence, and then I'm rasterizing everything. Just let me fix this camera. There we go. Then I'm converting the density into temperature, merging both of these guys together. And this is where it becomes interesting, because I'm setting the cooling rate to this value, but look at this value, which are set to 0. If I press this button, they will change to a random value between these two guys here. So this is this turbulence, and turbulence 2. This turbulence 2, turbulence, and this turbulence. These are the values I found the best. This is the block size of the instruments I liked. The cut fill is off, and the velocity is set to speed from 0 to 1. These are the settings of the turbulence. This is way bigger. This is going to be the big moving of the simulation, and this one is going to be the very small. This is going to be the details of this turbulence. And this turbulence is just the same. So these two guys are going to be driving the really big, the medium, and the very, very small details of this. The dissipation is going to be 0.3. I don't even know if I have smoke. I don't remember. Yes, I do have smoke, so the dissipation is going to be really quick, and the time scale is going to be also very fast. The temperature is going to be 3 because I wanted to raise a lot, and the velocity is going to be 0.1 because it was already too much. This is going to be the division size. It's going to be very small, and you will see this is how it looks. But the trick is on the Pyro bake. Very cool. So I'm just this is going to be stored, when I say to background, right here on fires version 1, and all these wedges, right? Then grabbing all these wedges, I'm doing a Pyro bake to see it a little bit better in this case. And okay, no, wait, this is very old. This is a setup for later on. Yep. And there was a small setup, the only setup which was made with the Pyro in this Houdini, which is basically a sphere with some ISO offset. This is the sphere, this is the ISO offset. I'm adding a little bit of noise here, the same for the temperature. I'm merging and I'm transforming this to the front. I'm converting this to BDB. Basically, this node is just converting this to a BDB. There's vector merging everything. There's nothing else going on here. This is also in my Patreon. And if we dive inside, we will see it's a simple Pyro solver part with a smoke object. The smoke object has this resolution. This is the maximum size. Let's see if we can see it better. Let's go to build. And it has a bunch of nodes right here. So let's go into the first frame, which is, let's check, which is a 950. There we go. So this is the maximum size. And what I am actually doing is adding a little bit of wind going to going upwards with a time scale of 0.4 with all these settings. So basically how it's saying how fast is it following the wind. Is a very cool mode. I'm adding a lot of disturbance with the block size of 1.3 and the strength of 12 with these thresholds with, and also the control speed is going to be this one. I'm adding disturbance with this block size, and this is the control, the speed again. I'm diffusing this because I want to have a little bit of blurriness on top of it. 0.02 should be enough. And I'm also dissipating with, based on evaporation and subtraction rate. Basically, I'm just removing density from my simulation, and I'm adding a vertical confinement of 2. This is another dissipate, but on the temperature this time on 0.3. And then this is the source. This is the collider of the VFX out collide SDF, which is basically everything. Then I'm importing the simulation with this convert again, with this volume visualization to see it better, and a time shift because I'm adding some frames on top of it. And this is how it really looks. So this is at the front, and it's actually very heavy, mainly because it's at the front, and this is how it looks from camera. So if I grab a Pyro bake, I visualize this here. This is how it looks without fire. This is the smoke. So this is how it looks. As you can see, there's the collider. This is a really nice thing that is actually colliding with the houses. I believe I remade this later on with Axiom. So let's have a look. Now, this is the same setup, exactly the same setup, but with Axiom. So it's the collider. This is the shape I want. This is the box. This is the shape, and this is going to be this is going to be for where I want the simulation to be working at. And I'm actually going to show you how this simulates. Let's go to the first frame, 850 right here. Let's press play. Now it will start simulating. It will also start colliding with the shape of the SDF. And if I go here, this is how it should be looking. So it's a very similar simulation. You can see it's very similar, but it was way faster to simulate in this case. Smoke, this, visualize volume. Let's view quality. Let's lower this. So this is how it looks. It's the same deal of it colliding with the collider. And the settings for this one are similar to the other one. It is turbulence to disturbance, one turbulence, the same confinement. Everything is based on speed, as you can see here. And the block size is just the usual, based on the division size. There's not much to it, to be honest, because it's just so simple. It just really works. If you wanted to have something else, you just have to change the block size. The block size is basically what's moving everything. You usually want to have you want to layer the effects on top of each other. So you would like to have a really small disturbance and a bigger disturbance, which, as you can see, it's the double. The same for the turbulence. You have this rule size of 0.05, and if I were to turn another one on, it's going to be the double, as you can see, or half in this case. But I do not want the turbulence.